quick nose blow before anybody shows up. All right, so let's see. Are we on Twitch? Am I on the right account? Okay, YouTube thinks we're live. That usually means I'm on the right account. Twitch doesn't seem to see it yet. Restream thinks we're streaming on Twitch. Am I logged in? Okay, Twitch thinks we're live. YouTube also thinks we're live. Awesome. Post a message. All right, welcome to Code Hangout number 218. Today we're going to look at some performance. And the spoiler warning is basically because I'm going to use Sudoku-vania, which is a very awesome puzzle that Skeptical Mario made. And using quite a few of the more advanced features, but they do task performance. And having played it a little bit yesterday and today, there's definitely some things I want to look at. There's a whole bunch of performance things that are on my long-term list. But I just thought I'd look a little bit at rendering performance, which I've spoken of before, especially in response to the large puzzle UI that I definitely need to look at. And I'm not planning to actually build any updated code today, but just more sort of taking a first look at it. So one of the issues are that I'm rendering via large SVG, and SVG rendering, you know, who knows how that works in a browser. And the blank puzzle isn't too bad. You can see it's kind of stuck at 60 FPS. It doesn't feel perfectly smooth, but it seems quick enough. You know, the puzzle is basically under the cursor and it catches up pretty quick. But once a little bit is filled in, because everything, every digit, everything adds to the complexity of the object, and there's filters and stuff, you see it's now at 40%, and now you feel it stuttering. And as I move it, it goes down to 20 FPS, and that's pretty bad. Let's have a look. If I zoom in, yeah. So just zooming in seems to cause a lot of issues. So it seems to be that the rendering outside of the screen seems to be one of the big problems. So I think one of the first things I want to look at is if I simply mask something off, will it render quicker? Right. So we're going to have a quick look at SVG masks. SVG mask, and we are using masks quite a lot to update the hidden and shown parts behind and in front of the or behind mostly the fog. But I'm curious if I simply put in a mask, and for that we're just gonna hard code it right at the top level of the SVG, which I think we can just do here. So if I just go to the actual SVG here in this HTML bit. And this is all super ancient code, like this should be generated in code and all this. So if we just put a mask in here, and let's have a look at the code in the fog feature, because that actually does masking, and maybe there's something in here, you know, that'll help us to figure things out, right? So for example, we can do something like this. And then we'll have something like this, mask. All right, so the mask SVG element defines mask for positing the current object into the background. A mask is used wherever it's used in the mask property. So we need to define the mask and then use the mask. So, okay, but it doesn't have to be in a defined thing. So here in the example, they create the mask, and then here they utilize the mask using the ID. Okay. And the mask could contain something like a rect. So if I just go in here and I say mask, could we, one of the issues is that I don't want to modify everything, right? Let's just, you know what, because I could also just generate it programmatically. Because I'm currently thinking, I can't mask the SVG itself, I don't think so. I would have to wrap this in a group, but I think there's some stuff that's depending on these being top level, right? So for example, if I put this into a G here, I don't think this will just work. Like if I do this, I don't expect this to just work. Yeah, in fact, it'll probably hit an error because it'll loop through the G's which aren't there. Yeah. All right, so probably what we need to do is we'll probably need to append the mask to each of these top level Gs. So first of all, let's create a mask. So ID test mask, right? And I think we don't really need to do much here. Mask type luminance. Mask type. Mask type. This attribute defines a mask mode for the type alpha luminance. Default value luminance. It's a brightness mask by default? Seriously? Alpha luminance. Is there an SVG clip mask? Clipping and masking. Ah, clipping is different from masking. But when you for clipping, clip path. So I'm SVG clipping vs mask perform. I would imagine clipping would have much better performance. I mean, we could just try it in CodePen. Maybe that'll be easier. So what we can do is we can take our if I save this and reload that, yeah. If we go here and we'll save this puzzle, just so we have, whoops, just so we have a large SVG file as a test thing, right? We'll say screenshot, right? We'll make it large, 2048 by whatever. We make it SVG off, blank puzzle off. All right, we download that. Now we'll do a new CodePen. New pen. Right. We'll go into code editing layout like this. And I guess we'll have the SVG here eventually. It's not downloading. Why is it not downloading? Did I abort it too early? Screenshot. Download. Keep. Okay, I didn't like the SVGs for some reason. Alright, so this should just be a blank SVG here. It's big, it's 500K. But the file shouldn't affect rendering. And we also want the FPS rendering, the frame rendering stats, right? So now if we take this and we'll just put it here. We'll save that. Okay. And it already falls, it drops to 30 FPS. That's crazy. So now the question is, if I just make this bigger or smaller, let's try something like this. If I say document.query query selector SVG. So if I just output that, we open the console here. Right, that'll give us the SVG here in the console. If I say, let's make a closure here. Let's make it async, we might need that later. And then we say let SVG equals, or const SVG EL equals that, right? And if I want to change this size-wise, we have viewbox, but we should also have just width and height, right? So console.log get attribute width. Boom. All right. So we can say let W equals this, and height becomes this. Oh, hey, Alfiana. Ooh, and Keith, how are you? Large puzzle guy on mobile one. Yeah, exactly. That's one of the features I need to work on to make all this stuff work properly. Thanks for saying that. I appreciate it. Work for what my mobile From this puzzle device related, but I'm not qualified to answer. Yeah, dynamic fog should work. Not in the app, just on the website. You can play it on the website. It's just a large puzzle UI, you know, because it's really just experimental. But it's part of what I need to build. And performance needs to be better for it to really work correctly. All right, so we have width and height. Right. Yeah. And we'll probably want to parse these. Right. And now we probably want to change these. Oh, okay. I need to have this open. I need to have the console open on the side. How is this visible on screen? Not very well, right? Because I'm not quite... So, because I am not streaming the full display. So I gotta do something like this, I guess. All right, so if I want to show rendering stats, so it's about 30%. So I just want to see if I make it much smaller, you know, what does it look like, right? So we'll do const svg set size equals width height. And we'll just say el width height, and we'll just say set attribute width w h. Right. So we should be able to do this. svgel. And now we want to make the width smaller and the height the same aspect ratio, right? So let's say the width wants to be 100, and then we'll want 100 times width over height. That should give us the right aspect ratio, right? No. Height over width. So if it's 79. So let's say if we do it 204.8, 204.8, 204.8, then it'll be 163.8. Yeah. Okay. So the new size will be, let's make it small, 100 and 100 times whatever, right? Just to see if that brings the frame rate up. If just scaling it down is enough for the rendering part of this counter here to be faster. Well, we're sitting at 57 FPS. Now it's not moving, but that doesn't seem to matter because before when it wasn't moving, it was quite large. Yeah, no, dynamic fog does not work in the app. All right, now if we do it very large, I'm expecting that frame rate to drop. Apparently it does not. Okay. Okay. Let's see what happens if we're moving it. I can do it either via CSS animation, or I think I'm just going to do it via an RAF. So we'll just say, we'll just do something like const handle frame equals time, boom, and then request animation frame handle frame. Right? And here we'll do something like blah blah blah. Actually, before we're doing this, let's just see if just modifying this will do the trick. So set attribute left, 100 px. Would that work? Does that move it over to the right? get rid of that as well. I think that's got to be a CSS property, right? So we want to do svgl dot c dot style dot left equals 100 px. Well, we probably need to do a bunch of stuff, right? We probably gotta do something like svg position absolute left 0 top 0, and then when we set left to 100 pixels we get this. Okay, so we can say how do we convert? We were time to loop. If I do, okay, let's do a set interval actually, because request animation frame will be fast. So if I, are you redrawing the SVG? No, but obviously as you're dragging it, I'm personally not doing anything, right? I don't control the rendering of the SVG. I'm not doing the drawing. The browser does, right? So as you're dragging it, I'm guessing the browser is redrawing it, right? And that's why when you're zoomed in, although it seems to be that even if I do nothing, you see here it's not bad. Here right now it's 30%. If I zoom in, it goes lower. So the browser is doing something. And I think it's when I move the mouse. Yeah, no, you see the browser doesn't actually redraw it, but as you're moving it. But even so, even like this, okay, see, right now it's 25 FPS. Why is it 25? Now it's 30. If I zoom out, now it's 30. Now it's 40. The thing is, it doesn't help if it's, if you're not doing anything, then if it's slow or not doesn't make a difference. So every time you feel it being slow, it's because you're trying to do something, right? Like dragging the puzzle, for example. And that's where you'll mostly feel it. So it doesn't matter. It still needs to be faster. And frankly, it is, the browser shouldn't have to redraw the whole thing when you're dragging it. It shouldn't. It should just move it around in the image buffer. But I don't have control over it, right? So I just have to figure out if there's something I can do. But right now, all I really want to do is a quick little test scenario to see if just raw SVG rendering is an issue, right? So if I say set interval, we'll do something, right, every 200 milliseconds, right? Let t equals 0. T++, right? Except we probably want to increment this by 200 and call it milliseconds, right? So now every 5 times per second, that number will go up, right? And we can now say something like math.syn t, right? And it'll cycle every, like this is radians, right? So we want to do divided by 360 times math.pi. Pi. So math.syn 0 is 0, I imagine. Syn of math.pi is that. T divided by 360 times math. Oh my god, my brain. It is 2 pi is whatever, right? So 0, 1, 2, right? If I do this, insert one above, equals sine. Oops. No. There's something with my numlock that's not working anymore. This is supposed to be... Okay. I don't know. Yeah. Alright. If we go 236 and pretend that's 360... Go down here. Grab these. Go down to here. Right? And we pretend this is 360 degrees. So we really want to do this, but it's divided by 180 times pi, right? Is pi a function? So one of... No? Divided by 360? Or divided by 720? Which one is it? It starts at 0. And it hits pi at 360. Ah, wait, what? Oh, of course, wait. No, that doesn't make sense. Right, if you divide it by 180, and by 180, okay, let's change these numbers. 0, 10, 20. We'll go in 10-degree steps. I haven't done this in so long, my brain is fried. I used to do this all the time. Now we can go divided by 360. Drag it down. So we're hitting pi at the end. Okay. And then sine of this autofill. So it hits 1 at 180 and then 0 again at 360. Yeah, 360 is a full circle. So this is exactly what we want. Okay. So it's 360 pi. I thought it was 180. Am I getting something wrong here? So 90 degrees is this. And then 180 degrees, pi becomes, sine of 180 degrees becomes 1. No, it should become 1 at 90. So it is divided by 180. Or is it the other direction, double, 2 pi divided by 720? No, that makes sense, right? So it's negative, so it goes to 1 by 90, it reaches 0 at 180, gets to negative 1 by 270, and back to 0 by 360. Yeah. Okay, so it is 1 divided by 180 times pi. All right, so if we divide it by 180, multiply it by pi, that'll get us the sine, and we can get the cosine just as well. And that should get us x and y of a circle, so we can just then wibble-wobble it around. It's just SVG. It's up to the browser how it's rendering the SVG. It's SVG. It can only be one or the other. I'm not gonna build my own SVG render. I'll leave that up to the browser. And if the browser is not optimal, I don't think I'm gonna do better than the Chromium team to build a performant SVG browser renderer. Okay. And then we want to multiply it by or whatever, right? Okay, so we can go now into here, and then this becomes time. Let x equals that, y equals that, and then here we'll just call handle frame t, right? And then we'll say this is x, let's say 100 times, or 100 plus 100 plus 100 times. So that should just give us a little circle, right? And then we should be able to do this. And that'll just be x. And we can just object Assign, style, boom, left, and top Y. We'll do that. And we're not using EL here, so we just get rid of that. And yeah. Unexpected token glows and brace. It's here. Okay. What does it get us? Yeah, I'm not interested in doing that at this point. I'll build alternate renders in the future, but not right now. 200 milliseconds at a time. We probably want to divide it by something then. So we'll do something like ang equals time divided by 1000. And then we'll use angle here. Just write it out. Let's not be lazy. Right. Divided by 100. So every second it should circle through 100. Okay, fair enough. So if I divide by 360, every second it cycles through 1000. So if I wanted to, I want to divide it by 1000, multiply it by 360, and that should give us one circuit every second. Yeah. Okay, but obviously our set interval is super slow, and that's why it looks super stuttery. So now we can go back to here. Nope. And here. There we go. All right. So now we see our frame rate dropping. Okay. And now if we set the size to something small. All right. So that's clearly smooth at 60 FPS. And if we set it to 1000, so it's definitely size. So it's I'm wondering if it's literally just how many pixels are being pushed. And what I'm doing here is I'm not modifying the SVG at all, right? So I'm just modifying the and it's funny because I feel like this feels less smooth, but it still says 54 FPS. So that's kind of odd. I almost want to set my own frame counter in here because I almost don't trust it. Shall we move two things? Actually, can we measure the duration of handle frame? Like, I want to see how many times handle frame gets executed within per time interval, right? And I could calculate that. But it's weird that it feels stuttery. Is it maybe that it's as soon as it goes below 60 FPS, because of the refresh rate discrepancy with my monitor, it immediately, like, this feels much smoother. There's still a little bit of a jagginess, but it feels much smoother, even though the FPS doesn't look different. So there needs to be something else I can look at. So I want to see, like, if I paint flash, you see, it doesn't even show that it's repainting here. Like, the buttons show, but this, it doesn't show as a paint refresh. And that's the thing that concerns me, is that it's like some sort of internal thing where it's clearly redrawing something, but it's not actually exposing it to me, which will make it very hard to optimize that. All right, let's see what we can find here. Vision deficiency. Image format. No. Plot frame throughput. Okay, well, we do have the performance tab. Current layout shift. Interact to next paint format. Your local NPM needs improvement. Okay. Can we clear this? This is not the performance tab I remember. Where's the profiler? Wasn't that the performance tab? Am I getting this wrong? Coverage, changes, develop resources, rendering. Where is the profiler? Chrome profiler. I remember something happening. Like they changed something about it. Did they just remove it? Is that possible? Where is the profiler? Like we're at the we are on the performance panel. Do I have to do record? Okay. Okay. If I make this bigger and then run another profile. And now I think we need to make the so here it seems to be clipping correctly. You see, it gets slower when I do this. Like now, super slow, right? 7 FPS. If I do this, smooth. And I'm guessing this will go up to 60 FPS again. I mean, this is definitely smoother than 12 or 13 FPS. Let's run a quick profile here. Just a couple of seconds should be enough. The frame counter still seems to be wrong. Can I restart it? Like, that is not correct, because this is butter smooth right now. This is very disturbing. Why does it look smooth right now, even though this shows a low number? The hell? Okay, so those are the redraws, right? And it spends all its time on the GPU. Well, okay. So, I mean, at least I know it's GPU accelerated. 8 milliseconds. It's so long. 8 milliseconds. It's half our total available frame time. All right, let's make it bigger again. And let's run a profile with whatever the hell this is. Okay. And now... because it's stuttering horribly, so you'd imagine these render times are longer than 16 milliseconds, except they're not. So what's going on? Because one of the alternatives I could do is I could literally render the SVG into... Let me try something. If it's not moved, no. Because I was thinking, like, I could temporarily render it into an image, move the image around, and then go back to SVG, right? Chrome SVG moving performance. Why does it is so sluggish? Oh, okay, so it seems to be a Chrome problem. I don't want to build my own renderer, come on. Yeah, like this shouldn't be CPU heavy. Oops. Latest stable Chrome, blah, blah, blah. The problem is, yeah, that's 12 years ago, and I would be surprised if any of this would ever get fixed. Apparently never going to go to it since this bug is over 11 years old. That was a year ago. Status new. Oh, geez. As the WireGate link is not working anymore. Yeah, this is also super sluggish. Okay. So, I guess we don't care about this. Or it does reduce the frame rate with a JavaScript animation. See the code example. In this particular case, it's done with dash circle CSS transform rotate. I mean, one of the other things I could do is potentially move. Let's try something else. What if instead of a fully filled SVG, because I was thinking like, what if we just move an outline, right? So instead of doing this, right? No, you see, it doesn't even matter if it's moving or not. It still drops the frame rate like crazy. Okay, well, the test I came here to actually do is to see if I clip the SVG file, does it still happen? Right. I'm just gonna put this up here. Right, so you see like this, when it's small, it's renders fast. But interestingly, it takes a while to execute the code of making it small, basically. Wait, now it's still relatively slow. What the hell? What if the space is smaller? So even... What? What? What if instead of doing this, if we just remove the whole thing? If we just remove it. H is not defined. Width, height, but it's right there. What do you mean H is not defined? What are you talking about? Right, well, it should be a flat out 60 FPS. What if we do something like display none, and then we don't remove it? Because I also don't know if this stat is updating correctly. And then we'll do something like set interval. We'll execute something in 1 second later, or let's say 2 seconds, and let's do this document.add event listener DOM content loaded. Actually, let's just say const start equals, right? And then DOM content loaded, start. Console log start. Right? Okay. So we'll get to start, we don't have a thing, and then 2 seconds later we'll ping, and we'll set the size to small, right? And we also do something with the CSS. We'll just say style display block. Like that. Ping, start. Ping, start. So if we do something like console.time start, and then we'll just do time end, then console.time show, And then console time and show. Oops. So now it should give us the timing of these things. Oh, except it doesn't show it in this console. Okay. So start is 0.3 milliseconds. Show is 200 milliseconds, which is mostly this. But then we could ask how long it'll take for the next interval, right? So we can do console.time show. Yeah, okay. So we know actually here it doesn't actually do anything, right? So we can do this, and then we can do set timeout, and then we'll just do we'll just end the timer, and we'll try to do it as soon as possible, and let's see how long that actually will take. Because I don't know if this will wait for the rendering to happen, I'll be honest. Set timeout. Why does it happen? Oh, set interval. That should be a timeout as well. Alright, so we'll have a start and then show 0.18 seconds. No, so that's almost instantaneous. Okay. Now, what if we make it big? How does that look? Also, show is basically super quick. And our FPS still looks big now. If I do this. Okay, sometimes it gets slow, and I don't know what does it. Is it maybe the text appearing on screen? All right, let's see if we can just refresh this. I'm just going to add a blank line and see if that should rerun the code. 0.44 milliseconds. So show. I assume that the problem is the renderer might not block on this. So it appears that show happens before the thing is shown. And I'm trying to figure out if there's a way I can force detecting when it's actually updated, right? So if I could render it into a canvas, and I could detect what the color of the pixels are, but even that's not necessarily corresponding with what's visible on screen. Let's see what happens if we are moving it in the meantime, even starting to move it before it's being displayed. All right, I still don't see anything here, and it doesn't seem particularly slow right now either. Now it's stuttering. Like it could also, it could also be something weird, like some threshold where if it goes bigger than a certain thing or smaller than a certain thing. Let me see if I can get the button to force the update. So if I say run. Show. But the frame rate is low right now. I wanna, you see, now suddenly it feels smooth. Just changing the window size a tiny bit suddenly made it feel smooth. Like, I'm wondering if there's some sort of threshold. Like 45 frames per second is probably enough to make it feel smooth. Can we measure the frame here? So if I say, console.time test RAF, right? And then we can just say, as soon as you can draw a frame, end this timer, right? And I wonder if I just do this every like 100 milliseconds or something. So RAF seems to take around 6.8. The problem with that is I don't know how often that'll run. So I think I actually do want to have like an FPS count, like build my own FPS counter quickly. So what we're gonna do is we'll just count up a timer, and then every second we'll just show the timing, right? So we're just gonna have two variables. We'll have something like let frame count equals 0, frame time was 0. All right, and then we'll just say we'll have a function. Here we're just gonna say we'll just say if frame time equals 0, we'll start the frame counter. So to start the frame counter, or to reset the frame FPS measurement, we just set frame time to 0. If I'm trying to think what my normal way of doing that is. No, we'll just measure for a second, and then we'll see how many frames we rendered in that second, right? So then we'll just say if frame time is 0, we'll just set it to time, and frame count to 0, right? And then we'll just increment that. And now we can just say something like set interval every second, console.log FPS, and then we'll just set frame time to 0, which should trigger the reset here. 0, which will, yeah. So our delta time is frame time. Actually, we want to set frame time always to time. And then we'll just want to have FPS time equals 0. And we'll have FPS time 0. FPS time equals... No, actually we don't need to do this in here then. All we really want to do is this and frame count. And then what we do here is we'll have a function const measure FPS time, or delta time equals 1000 milliseconds, right? So when we say measure FPS, we measure the current frame time. Start time equals boom, frame time, right? Start count equals boom, right? And then we'll do set timeout something dt. And then at the end of the timeout, we'll have let delta count equals frame count minus start count, and delta time equals frame time minus start time, and then we'll just return that async. Then we can return delta count. Oops. Delta count divided by delta time times 1000. And then here we'll just say every 1000 milliseconds we'll do this async, And then here we can just await, measure FPS. And that's, I think, all we need to do. I think. If I rerun that. That's so far from where we're optimizing. Right now, you know, this is all browser stuff. I don't render it myself. This is not a low-level application, right? Measure FPS. Can we not return from set timeout? Async. Async. We need to do a little promisey sleepy thing. Let's just grab my sleep function from utilities. Blah blah blah. Utilities. Find sleep. Sleep. I'm not gonna rebuild that from scratch. Put that here somewhere. Boom. Sleep. All right. So we're just gonna do await sleep 1000 or DT, right? Duration, and then we'll do that. Boom, boom, boom. Oh, and that should get us a async function that after 1 second returns what the FPS was for that duration. All right, so we're getting 60 FPS, right? So if I now make this bigger, it dropped to 30, but now it's back up to, okay, now it's at 5. All right, so this is exactly the same image. It went from 30 to 5. Yeah, so now it's stuttering, and even when we're getting smaller, so there's definitely something weird going on. And I'm afraid it's something related to actual browser bugs. Like you see how it goes smooth for a bit and then stutters, and then goes smooth and then stutters. Okay, let's not move the thing and see if that makes it any different. So waiting to show it obviously doesn't mean anything. So we can get rid of that. So we can just set the size. We make it visible. And then we'll start that. We don't need any of that. And then we can just do this. And then we can get rid of that. So we make it big, we display it, and then we measure FPS. FPS, NAN, NAN, NAN. Is this not an async function? How is this suddenly not working? Huh? Okay. Duration. Start frame. Start count. So that should trigger every second, right? Measure FPS. Start time, start count. Frame time. Oh, because we're not executing this. Ah, I'm an idiot. Okay, so we still need to run this. We're just not gonna execute any of this stuff. So we're not forced. As far as I'm knowing, there should be no re-rendering. Yeah. So we're at 60 FPS. 60 FPS. It goes down when I'm resizing, but then it goes back up. So that to me implies that it's redrawing the part that's off screen, which implies to me that it's also clipping. Because one of the things I'm thinking is, one of the sort of cheaty things I could do is I could, when you're dragging it, it just drags a version of the puzzle without details, right? Okay, so now let's try the clip mask. Ah, wait, no. Okay, so it doesn't seem, it seems to be fast when it's not moving. Now, if we're moving it, that should immediately make it slow down. Now, I guess what happens is that eventually it might buffer the off-screen bits. Okay, so you see now suddenly it did some sort of optimization, and now it's hitting x 60 FPS, but it was stuttering until now. And that's a bit problematic because I don't have any control over that. Ease on your animation to linear. Run the simple and see it run without the clunky slowdown. So I'm wondering if there's other ways of moving it, right? Like if I use, instead of using width and height, if I use transforms, for example. But I'm already doing that in the actual render in the thing. Now, if I scroll, it stutters. Does it eventually catch up? No. Okay, let's try the clip mask, right? So earlier I was looking at masking versus clipping, right? Rectangle shape clip path, HTML, mask, clip path, polygon, clip path. So the clip path gets applied how? Same as the mask, basically. All right. So if I go to the HTML, we're here, right? Okay. We have all of this. Defs. And we want to clip everything. So let's do something like this here. Clip test. All right. So this goes from 0, 0 to whatever max is. I think I could just write 100%, right? 100%. 100%. And then we want to create a G here. Ah, no, we want to clip it to something small. So 100, 100. And then we want to clip test. Like that. And then /G at the end here. Like that. Now, if I refresh that, it should just give me a little square. Okay. Now, if I scroll, it's still hitting 60 FPS. Okay, because what I'm wondering is if simply clipping the puzzle to the visible screen is enough. If you see what I mean. I mean, obviously, we would have to dynamically update the clip mask, which could be problematic, right? But the other option would be that instead of moving the whole SVG, which is, I think, what's happening right now, if I go in here and I move that, I'm just moving the SVG, right? So the SVG is always there. But if I were to move the SVG inside another SVG, for example, right, and then clipped the other one to the screen, you know. So let's try something else. Let's try something else, and let's create another SVG. Okay, 1 second. This frame rate thing up here is kind of in the way. All right. So SVG ID equals outer. We need to be a bit careful. And this is fine. We have SVG outer. All right, SVG. Get rid of this. Get rid of this. Right. And we now grab SVG hash outer SVG. And I'm just gonna save this here for a sec. Console.log this. Right? If we run this, this is the inner SVG now. Okay. And now, if we modify the console of the inner one with something like... wait, first of all, why do we still have clipping? Oh, yes, because the outer one doesn't take up... Oh. The outer one doesn't have to take up all the space, right? So, first of all, position absolute, left top 0, 0. This SVG should... This should be at 0, 0. So I'm guessing we need to make body margins 0. So body margin or padding 0. Right? What is the space coming from? Elements. Elements. And nope. Body. SVG outer. SVG inner. Viewbox. Where does the spacing come from? Is it from the viewbox? Why is this offset? Should I disable the movement? Yes. Left. If I say left, make it -50 px. It probably has something to do... Oh, no. Wait, no. I think the SVG just is like that, right? It has like a white thing, part of the SVG. I don't know why it's not showing here when that's selected. Okay, let's do SVG hashtag outer. Hashtag outer, oh my god. Width 100%. Right, 100%. Like, make it fill up its parent. Okay, let's skip the resize for a sec. Let's also skip this, the display block change, and let's get rid of this. Okay. Yeah, I think the SVG has that white space on the outer edge. Okay. Now, if I make the outer SVG smaller, so let's say we make it only 50% of the container, does that automatically clip the inner SVG? Maybe. Now, if we're moving the inner SVG, right, and we put the movement back, And ideally, we'll do this as a transform. Translate XY. And we'll put that in here, put that in there. Oh, I'm in the wrong mode. All right, if we do this, translate XY. That doesn't seem to do the trick. So transform, translate X. Oh, translate. Oops. 100. 100. Okay, so it's not translate XY, it's just translate. And there's translate 3D. All right. Okay. All right. That seems to be smooth. Does it depend on the size of this window? A little bit, because it's a percentage of it. Okay, now if we make the outer one bigger, sorry, the inner one bigger, it shouldn't affect it if the rendering only depends on how much is being rendered. SVG set size. No, we're sitting 60 FPS. If I make it 10 times larger, are we going to hit the same thing? Still 60 FPS. Okay, now if we make the outer SVG 100% of our view area, so it seems that nested SVGs act as some kind of clipping. It is slower, but I don't know if this is related to this being 100% of the screen size. So let's make it super tiny. So 60 FPS here. All right, so if we put this at 50/50 and then this at 5,000/5,000, we get to here, 60 FPS. And if we make this 10,000, so twice as large, still 60 FPS. Now, as this gets larger, I guess it'll slow down. So it's literally how many pixels is it drawing on the screen. It's really annoying. Now, let me try something. Just trying to think where is it the easiest to do this. Because we have a way of turning an SVG to a PNG, right? It's in here somewhere. SVG to PNG, somewhere. Or is it puzzle tools? Probably under puzzle tools. SVG to blob. SVG to data URI. SVG. Ah, no, we want SVG to image. All right, so if I go in here, right, puzzle tools dot SVG to image. So if I do this, async await console.log await, right? SVG to image. SVG to image. Data. Where does data come from? So if I do document.query selector SVG, that gets us an icon. Okay. Frame work dot app dot puzzle dot render app dot render SVG renderer dot SVG elem right dot outer HTML right, and then if we do this, okay, what if we just execute this? This should give us a promise, right? Yes, yes. Okay, let's just do that. Right. This is JavaScript. Give me some colors. We want to do this. Want to do this, this, and this. We want this to execute. Yeah, that wasn't executing what I had in here. That's why this wasn't working. Okay, that gets us a blob of an image. But we can use that. So let's go back to here. We will need some of these tools. So we'll need, let's move that down here. We'll need image to, sorry, we need SVG to image. So we'll need SVG to image. Like that. We need data to blob URL. Right? And the data comes from there. So this gets us an image object. Okay, I was thinking of canvas, rendering it into a canvas, but this might work just the same. So it'll give us a large image, but the question is moving an image going to be the same kind of problem? Because if it's just rendering pixels, then it shouldn't matter if it's an image. And it's just, okay, we can't move that many pixels. Of course, it shouldn't be redrawing them. It should literally just shift them. And it should definitely be able to do that. All right, let us skip all of this for a sec. We have the handling here. We have the skipping here. And then we have the actions here. So we have SVG EL somewhere up here. SVG EL dot outer. All right. So if we run this, what's going to happen? We're getting the image. We're getting the image. Okay. So we should be able to do something like let img equals this. And then we should be able to do something like document.body.append child img. Let's call it the SVG img. Oh, let's just call it the img for now. We don't have another one. And that should sit somewhere. We don't know where. But let's grab that and do that. And frankly, I should be able to find it here. That should be the image. Okay. Yeah. Can we just move the image around now? So let's skip that. And then instead of this, we'll do something like that. Right? Just say boom. We'll do that. And then here, instead of doing this, we'll do it on that. And if we run that, does it have the same problems? Yes, it seems to. So it doesn't matter. So it has nothing to do with the SVG. Or does it? We can do something else. So we're gonna do document.body .inner HTML equals nothing. So blank slated, right? So that should get our FPS straight up to 60. Boom. Nothing on the screen. FPS 60. Okay. Ignore that. That doesn't seem to update correctly. Now, what we're going to do is we're going to put a div here. We're going to give it an ID. I'm going to call it redbox. And then we're going to give it a style. The style is size equals position equals absolute, left 0, top 0, width 100%, height 100%, background red, outline 10px dashed red. Let's make it 90% width and height and see if we're gonna get our box. Okay. Left 10. Let's say 10%. Top 10%. Right? That should get us all of the box in the... Nope. Now we have to make this 80. And that should give us a 10% margin around the outer edge. And it's not a lot of pixels to be rendered for now. So now let's see what happens if we move redbox the same way as we did these. So we'll now do document.query select or redbox dot style, and then we translate that. Did that just crash? Very possible. Okay, so we're still hitting 60 FPS. Let's fill it in. Background orange. Oh, well, it's supposed to be background red. Let's give it a blue dashed outline. Now, obviously, this is without clipping, but I'm just checking what happens if we have SVG setting no grid. Where did that come from? Okay. Now, if we make it much big, can we get a pattern? CSS fill pattern, just so we see it move. We don't want to do that. Is there no fill patterns without SVG? Because then we're back to SVG rendering. Although, what if the SVG as a background image in a moving diff would render more efficiently? Not the craziest thing I'd ever heard here. Okay, let's make it 500%. I mean, we're still moving pixels, right? It's still smooth. Uh-huh. Okay. Justify items. Yeah. Background image. So what if, before we do this, so the SVG element might still exist at this point, right? So if I say console.log this, that might actually still exist, or is because I set this to nothing? No, that still exists. So we could, in theory, give this a fill pattern just using CSS. Fill. Where did I just see that, though, as an example? Like, there was something here, background image, right? Parent is filled with an SVG just right. You can plop it right into CSS and have it remain fairly manageable. If you encode the SVG just right. Okay, we don't want to do that. CSS SVG as fill pattern. I mean, we have the image as well, so we could try to just simply use that as a background image, right? We have data to blob URL. So potentially we could also just say image.el.src and just pull that off as our background image. Yeah. So we should be able to just say document.query selector red box dot style dot background image equals URL image el.source. So if I do this, will it get the puzzle as a background image? And how does it like that for movement? Not found. Ah. Okay. Oops. No. Get me back to my untitled. Here we go. SVG rendering performance testing. Oh no. I think my browser just crashed and restarted. Everything fleshed. Are my streams still working? That's always scary when the Chrome is so unstable. I don't know. I think there's something wrong with my memory as well. Okay, so that drops the FPS now. So that sucks. And I don't know if, how am I creating this image right now? Data to blob URL. SRC. Let's try converting the image to a PNG first. Image to PNG URL. Image to PNG URL. Or is image to canvas enough? If it's a canvas, it should definitely be pixel data, right? And it crashed again. Okay, yeah, I think my memory isn't stable at the clock rate that it's at, and because Chrome uses so much memory, it's the one tool that manages to just mess with my computer. Like, I don't know what you guys see on your end, but on my end, all tabs go black. But then they all come back very quickly. So I think it crashes them and then just restarts them all. But I don't know if it hits like an out-of-memory condition. I mean, I could just kill some of these. Those I need. Email I don't need right now. Oh. I didn't need that one. Don't need that one. Untitled spreadsheet, probably don't need it. Probably don't need that. Probably don't need that. That I need. Don't need the email right now. All right, that should be a couple of gigabytes of memory released. Jesus. All right. So, if we add this, this should be asynchronously rendering an image to a canvas. We can't use a canvas as a background image, unfortunately. We need a URL. But we can get a PNG URL from it. So what we can do is we can do this. Right? And that should get us what? That should get us a canvas element here. And then canvas should have mdn canvas to URL. That should be able to get us a data URL in the format PNG. Right. So then we should be able to do to data URL image/PNG. And right now my computer is barely usable. It's stuttering so badly. It's 3 frames per second. But of course my CPU is basically unused. Image to data is not a function. Image to canvas. Canvas.toData URL. ToData URL encodes the whole image. Capitalized URL. Okay. So if we run that. Okay, so that's our data URL. So maybe we can use that instead of this one. Like, I just want to know if the rendering is dependent at all of where the image comes from. So apparently an SVG loaded into an image tag is still rendered via the SVG renderer. Huh. All right, do I have a shortcut for going... well, what the other thing we can do now is we can, instead of using this, we'll convert the image element first to a canvas using this thing here. So image element equals image to canvas. So now it's a canvas, just different DOM element, right? But being a canvas, it's now raster data. And image to canvas. Huh? Canvas has a style element. Oh, wait, but this doesn't exist. We want to do this one. Okay. Come on. Yeah, because it's hitting that error every time, 6 times per second, so it's a bit backed up, I guess. But it shouldn't be so bad that it's not able to restart. Come on, restart. Yeah, apparently that did freeze it. Okay. Code pen, that is not good. That shouldn't freeze you up. Alright, we can restart this and this. We're not removing the other elements though. Okay. So that moves a lot smoother. So then the question is, can we do this after resizing the SVG? So if I do this first, and then do that, gets bigger. Now this is a ginormous canvas element, right? With a lot of pixel data. A lot of pixel data. But it's going at a butter smooth 60 FPS. So this is what I was trying to get to. So potential, because this is one of the optimization steps that I've always anticipated, is basically not rendering the entire puzzle as a dynamically updatable SVG, but breaking it into pieces where the pieces are basically cached as like tiles, let's say 100 by 100 pixel tiles of PNG data that are just aligned in such a way that they replicate the total thing. But as you're interacting with the puzzle, it just moves, it just makes the SVG available for that interaction. Now, the question is, how long does it take to render this process? Because obviously, if it takes multiple seconds and everything freezes up, we can't do it very often, right? So we could do it at the start of a drag operation, right? Or, and that's the question is, can I easily subdivide the SVG itself and render that into pieces? I mean, that the ultimate optimization is to have the whole SVG broken into individual pieces. But then the internal code will struggle, right? Because my code isn't designed for that. If it's just a pure rendering problem, is then we could just always render it invisibly into tiles, and have, well, the problem is the interactive part, right? The moment we change something, although I'm trying to think right now, if my interaction with it actually interacts with the SVG itself, with the DOM, I don't think it does. I don't think the SVG needs to be visible here for this interaction to work. So for example, right now, this is slow and stuttery, right? Stuttery. But if I now do document or whatever framework, so if I take the SVG element, right? And I'll say .style.display none. Right? I think this still sort of works. If I do Control A and do this, and then I say display block, or display auto, inherit, Where is it? Okay, I thought this was just gonna work, but clearly it's not. SVG render here. Display. If I get rid of this. But where is it? Why can't I see it? Where is it? Oh, there it is. Okay, all right. So the interaction worked. So then the question is, how long does it take to turn it to an image? And I think we can calculate that using that little thing here, right? So if I go back to in here, right, and we add that other step of image to canvas, right? So puzzle tools dot image to canvas, boom, right, and then we'll do console dot time svg to canvas. That can equals s equals end, right, and console.log canvas. So if I do this, and right now it'll be a bit slow because it's doing it while our sluggish slow rendering is actually happening. Unexpected tokens, semicolon. Where? Oh. This wasn't a multi-line function before. If I do this, 79 milliseconds, right? So that is one of the problems with this, is that once we want to move from the puzzle to the canvas, it could take a long time. The other question is if I do it in segments, because then I don't have to render the whole thing. I'll just have to figure... The big problem is like, right, if I do a Control A, all of it needs to update, right? Because we're selecting all of the things, right? But we could also potentially detect what's off screen. So for example, you know, whatever tiles are overlapping the screen and only update those. And then it doesn't matter how big the total puzzle is. It still matters internally, but this is clearly a rendering issue, right? Image to canvas does this. So we do image to canvas and SVG to image. Now the SVG to image to PNG, SVG to image, SVG to image, data to blob. Like there's so many steps here and I don't know if I need them all. Image to PNG, SVG to data URI. Maybe it's better if I do this. SVG to data URI. SVG to data URI. So if I do... So this is around 60 milliseconds, right? So if we're doing SVG to data URI, and we're passing in the SVG. Okay, so first of all, we do const SVG equals this. Right. Then here, we'll do SVG to data URI, which is not async. It's just a string operation. To go from data URI, we still need to go to... okay, so we still need to go to the canvas. But we're not going via a blob. We're not generating a blob. So URL to image, which is this. Which this should really be using that. Yeah, that should really be using this. But let's just do this for a sec here. URL to image, that gets us the URL. So instead of a blob, I don't know if the blob mechanism is slow. But this way we're definitely skipping it. And then we can do... and URL to image is also a promise. Right. And then we can do that. Like that. And we can do this. And now we should also get a canvas. 74 milliseconds. So it seems to be basically the same amount of time. So if we do this, opening the canvas isn't going to help us much. And then here we'll just do this one. The only thing I don't like about this timing, doing the timing like this, is I don't know if this is actually gonna be favoring one or the other, you know, some kind of pre-processing caching. Like running this many times, depending on which one gets run first, might make a big difference. But it seems to be around 44, 55 milliseconds. If I don't do the... I think I want to avoid the blob. So for now, let's not use that. And if I don't do the image to canvas at this stage, right? Is that the specific amount? Because this step, I cannot reduce the amount of data I'm handling, unfortunately. Maybe I need to look into SVG to image after all. So if I do SVG to image and go straight from that, how's that? 30 milliseconds, 20 milliseconds, 30, 20, 20, 30, 20. Because even though it's just a string operation, it's a big string. Is there anything else I can... Oh, and the other problem I have is... And I saw that with when I do the screenshots, is that if I render the SVG like that, it might not have access to browser-based styles and things like that. So the fonts might not be right, etc., etc. And getting all of those into this SVG text is a bit complex. I do it, but if we have to do it very often, but maybe we don't have to do it completely, because we could maybe cache a whole bunch of that, right? Like we wouldn't have to parse all the styles and all this stuff. But there's still a bunch of string information, and the HTML, you know, the SVG data is like 500 kilobytes, right? So even the string operations alone could be problematic. But let's see if there's something here. So the question is, if I time this, right, separately, and then we'll time img to canvas separately, right, and that's just now image to canvas img, because that we can speed up by not rendering the entire thing, right? Except that barely takes any time. But maybe because the canvas is not very large. But it should give us the full size. Yeah, that doesn't make any sense. Wait, what? What's going on here? Why is this not the full size? The image... Image.width. Can we see the width of the image here? 187. Why is the image 187? That doesn't make any sense. If we make it the size it's supposed to be, I don't know, or something. One second. All right, if we do this, and then we'll do document.body.append child ing, and then ing.style object.assign position absolute top 0 0 left 0. So if I do this, we're seeing something here. Yeah, so here we're seeing that the image doesn't get rendered correctly. And I'm afraid if I make it render correctly, like go through all the stuff that the screenshot tool goes through, basically create a thumbnail. Create thumbnail. Is that what I want to go with? Is our screenshot tool right now using create thumbnail? I'm not even sure it does. I'm not sure if I've ever updated that to use create thumbnail. So, solve puzzle data, associated data, image. I think this doesn't even use create thumbnail. Because this is doing all the hard work of getting everything to work correctly. And I think elsewhere, I'm even using this. I did this recently, and I don't remember exactly for what. Like, the create screenshot function needs to either get updated to do it this way, or this needs to get updated to use that one. Yeah. We're doing it here. We're using update screenshot. So the question is, how long does that work take? Data. Where am I even using data? I don't even think we're using data here. Create thumb. Data. Search create thumbnail. Ah, okay. I think data is literally just options. Which I'm not even passing in here. Huh? Data. Data. Create thumb. I don't think I'm using data at all in here. Okay, so framework dot features dot project 9x9 dot create thumb. It's an async function that creates a thumbnail. Okay. What kind of thumbnail? If I do this, wait. Excuse me. Holy moly. All right. Can just do this, right? So that returns a blob. Okay. In how much time? In how much time is that happening? Ooh, my nose is itching. 200 milliseconds. Yeah, that's not helpful. Now the question is it this long because of manipulation of the SVG data? Or is it this long because of the time of rendering the pixel data into canvases, images, or whatever? Because if it's the former, I'm screwed. If it's the latter, then maybe rendering to tiles is the solution. So, Project 999 does update screenshot, image URI to blob. So let's do some timings here. So we have an update screenshot timer, right? And then we'll do a timer for image URI to blob. For now, I think those two are the main steps here. If I do this, and then I'll do this. Holy moly, it takes forever. And obviously there's a lot of optimizations to be done in the opening of the puzzle and the startup timing and all that. I definitely want to work on those as well. But, you know, so many things, right? Okay, so image UI to blob is very fast. But in this case, the image right now is still SVG data. Right. We're deleting last options. We're updating the screenshot. But where do we tell it the features that we wanted to use? Options. Find options. So here, I'm guessing I'm just using the default options. Okay. So we'll probably want options to be set somewhere. Load options, saved options, default options, save options, set options. Handle option change, that option, that option. All right, let's cut the middleman out for a sec here. Right? So if we just do that here. Okay. Do we use anything here from... Hey guys, do we use anything here from Project 9x9? I don't think so. So we can just do this. I don't think we have any local references here. Then we can just do this. For now. Right? Okay. Now, if we change the options using set option, and let's do this ahead of time, why not? So we'll do framework dot feature. You know what? Put these here. Then we'll do screenshot dot set option with, I don't know, 5,000 height, 5,000, and I'm guessing type PNG. Now if we're doing that, that's when it should have the more expensive rasterization thing. Off now, setting value. Cannot set what of now? Wait, what? 5 133 133. Oh, that sucks. Okay. We probably want to do this directly. Right, so we'll just say options dot type equals PNG, and then I'll just say object dot assign type PNG width 5000 and height 5000. Just make sure we have a large image, because I need to know if there's a bottleneck when it comes to, you know, a large size of image, because if it's not full resolution, then it doesn't help us. Okay. Uncoded properties of null. Properties of null. Blob.type.match. Okay, we do this. If I get rid of these, I just want to see if something's broken right now. It could be just broken because... Okay, so let's refresh that and see if we can do this again. No. Promise pending. Okay, that's the whole thing. Update screenshots. Create thumb. Okay. If I try to output the type here. What I don't know is if there's some internal state that's currently broken in the screenshots feature. Text HTML. What? Okay, that doesn't make sense. All right, let's refresh this. Do this. And rerun this code. Okay. Image PNG. Okay, so default is PNG. Okay. What are the default options? Default options. Maybe the PNG was supposed to be capitalized. Very possible. Don't know why I would do that. I probably shouldn't. Okay. If I rerun this. Alright. So the size change definitely made it slower. 581 milliseconds for update screenshot. Now, what does update screenshot do? Is that only SVG manipulation? Because it does so much. Even it does to emoji, like it does substitution of emoji symbols with SVG. And we have this in here. Okay, if I do just SVG like this, what does that look like timing-wise? It's still a complex operation. So it's 204 milliseconds. Okay, so that's not crazy. It'll be a stutter, but it's a fifth of a second. It's quite a wait, because I'm thinking, for example, could we, the moment you click down to drag, do we have a fifth of a second? You'll definitely feel the stutter. if the rendering of the tiles then is sub-frame timing. The alternative would be to do it at another time when you're not dragging it, right? Let's say every time you manipulate the thing, if we had more than 500 milliseconds of idle, we'll just do that 200 milliseconds to update that. The problem is there'll be a stutter if the user wants to do something in that moment, right? Because I'm pretty sure this operation is fully blocking. Unless we'll do it in a worker thread. Ugh. The other alternative is to update this SVG text in some sort of smart way, right? So we're not, because I think part of what makes this a bit slow is that it scans through the whole document for runs the replay, which we definitely don't want to do. If blank. So blank should definitely be off. We definitely want to do console.log. I'll put that. Because maybe we can just have all the other SVG static and then just substitute the SVG that's the inner HTML from, or the outer HTML from the element, and cache the rest. And maybe that's just a quick string substitution. So I don't know if it does anything else to that raw SVG data. I'd have to dig through this. Like, we're doing some SVG substitution here. The Trimoji stuff might be something that would have to be rerun. Yeah, that's definitely complex. Ugh, holy moly. I don't know if that's the slowest part of it all, though. So if we're not rerunning this, and if replay, let replay, decode, replay. So if blank is not, okay, this just restores the replay. Okay, so I think not rerunning the replay to get us a blank puzzle already saved us a quarter of the amount of time. So 188, so 32 to get the blob. The blob isn't useful to us. Where does the blob get created? Is that over here? Yeah, so we don't really want to do the blob. So we'll do this. Right. And preview image .src should now be our basically source code for the quote-unquote screenshot, right? Yeah. And that is SVG data. How? Why? Image to canvas. So now the question is, so this just is get us the SVG. So get SVG. Let's call it that, right? Options, and then we'll just do this. Options. And then here we'll just say get SVG. Options. And later on we'll figure out the exact sizing and all that. And we don't need to do that here anymore. And this one will be blank false, trim false, yada yada yada. And then here we'll just return this. Okay. And I don't think that is useful. Okay. That should take us around, what, 150 milliseconds? 140 milliseconds. Not great, but not the worst. Not the end of the world. And now the question is, can I render this into a PNG image at a certain size within a very, very fast time frame? And then I can do it many, many times for these different things, right? So here we have SVG to image. This is the image to canvas. This is the one that'll potentially do the trick, hopefully, right? So, so here we want to get image to canvas. We'll want to get an image. And then we'll want to do an X, Y, width, height. And that's basically what gets rendered out of the main thing. And this is just gonna be... We don't care about the width and height of the original image. Right? And then... I think it's enough to just do XY here. So if I say image to canvas here, like that, and then we'll say let canvas equals image to canvas get SVG. Now get SVG should return what? Source, which we need to turn to an image. So we need URI to image. Pass to SVG, engineer. We did that over here. No, we did that over here. Image to canvas, SVG to image. Image to canvas, SVG to image. So SVG to image. So we still need to do a blob conversion. Because that gets us an SVG data URI. SVG to data URI, then data URI to image. It's basically URL to image, right? So we want to do that. All right. So then we do let image equals URL to image. And that should be URL to image. Right. And URL to image, is that... I'm guessing that's async. Yes. So we're going to await that. Await URL to image. And then here we just say SVG URL. Right? Then we time URL to image. And then image to canvas. And image to canvas, is that also a image to canvas? That's synchronous. Okay. So if we just do this, that should already work. Nope. Image to canvas is not being dereferenced over here. Oh, wait. Image to canvas has already been declared. Oh. Don't need that here. Okay. And... Okay, so 12 milliseconds. It's weird that URL to image takes that long. URL to image. Is it because of the data blob? Ah, wait, no, but URL to image doesn't use data blob. Okay. Now, this image to canvas is... Oh. I just deleted that from here. I was working on my own here. Okay, image to canvas. We want to do an image to canvas over here. Image to canvas 2, let's say. Okay. So image to canvas for the full thing, and then image to canvas 2. let's say 100, 100, and a 500 by 500 size, starting at 100, 100. Let's see if that's faster. It is. Okay. So we should be able to do something like document dot body dot append child canvas 2, and then object dot assign canvas 2 dot style, and it'll be position absolute, top 0, left 0. For now, let's see what we get. Nope. Let's see what we get. Okay. What if we do it with canvas 1? Does that get us something? Okay, so that gets us the whole thing. So this is very possibly a problem because it's so big. So honkin' chunkin' chunky. If we do this and this, and go back to canvas 2, they're gonna work? We'll probably want to refresh that and get rid of the noise. Canvas 2. Canvas 2. Delete that. Let's just rerun it because it could be that the puzzle wasn't ready yet and we got nothing in our canvas. Okay, there's something not right because it seems like the canvas is completely transparent, which doesn't seem right. Ah, okay. So this is now a canvas, and it's 5,000. Why is this 5,000 by 5,000? Oh, I made it 5,000 by 5,000. Really? X. Oh yeah, I forgot that I stretched the puzzle to be 5,000 by 5,000. Okay. I don't know if we need it that big. I mean, it is an SVG. That actually doesn't affect the size of the thing. Okay, fair enough, fair enough. But this happened fairly reasonably quick. Let's say if we make this 1,000 by 1,000, and X, Y, X. Wait, am I misreading the draw image? I think Toby's still waiting. Dx dy destination xy. So no, dx dy we want it to be 0. So this is actually always going to be 0, 0. And then we have x, y, width, height. We actually want to do this. Yeah, I got my arguments wrong here. All right, if I do this, on camera overloads resolution failed. Destination XY. Source. Oh, source width height. And then destination 0, 0 width. Right. I always felt that there was one overload missing where you just draw the full size of the destination canvas. It always made sense to me. Okay. And now this is the canvas. And how big is it? It's 1,000 by 1,000, which is honkin' chunkin' big. Let's make it a bit smaller. And now it is 500 by 500, and it's there. So if we bring the Y up like that, or down more accurately, canvas, get rid of it. Go back here, do this. All right, so now that should grab a 500 by 500 square from that space. And this specific image to canvas took 1.5 milliseconds. So now the question is, can we do this a bunch of times with different parts of it? So if we do this, let's say exit by 4, right? And then we'll just say we have a 1, 1. And that'll be here. Or let's see. And then we'll just say C is this. Pen style. C style. Da da da. Right? And then we do this again. But this time plus 500 plus 0 plus 0 plus 0, right? We'll swap this. And we'll make this boom 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 EX. Boom 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 EX. Right. And now this one will be 500. Like that. So it's not times 4, it's times 2 for now. Just to test it. And now a full screen this, we get these two canvases here. They're distinct canvases, but they're perfectly matched. Okay, so now let's do all 4. By all 4, I mean just let's do 4 of these. I should put these in a function, but it's fine. So we'll do the Y at 500 as well. And the Y will be, or the top will be 500. So now we should have 4 tiles, making a 1000 by 1000 square. And then the goal is that in theory, in principle, we could, you know, update just bits that are visible on screen. And so what I wanted to see is how, yeah, so creating 4 of these is 13 milliseconds. So it seems to average around 5 to 10 milliseconds each. So as we're moving these around, we don't have to update them. And the idea, especially when we're moving them around, and we only need a bunch of these. We don't need, if the puzzle is much larger than our screen, we don't need all of these as things. Now the problem is that most of the time is spent here. So let's try something else. So if I zoom in all the way, right. So now if I move it, it struggles. But if I go frame work dot app dot svg renderer dot get content bounds. If I do this, right? Left, right, 3200. Width. Height. So it's 3200 at this stage. Which doesn't seem right, because if I zoom like this... Okay, so this doesn't actually give me the zoomed version. So if I go into large puzzle mode... Puzzle. Large puzzle UI, where is it? Large puzzle. Right. And then we're zooming, and when we're zooming, because it's actually a little complex, the math for it, because I wanted it to zoom towards the cursor, which was a bit of mathy. Then we'll zoom pan, zoom level, update transform. So update transform. So we're just modifying the scale and all that, which means we're going back to here. And we'll zoom in. We'll look at this element at the SVG. This SVG now, what gets modified? SVG doesn't get modified at all. It's the board that gets modified. We have a translation. Scale is 1. Oh, it scales to 1 at its... Does this make sense? So if I scale it down, does it make these smaller? No. So the content bounds don't take the scaling into consideration. Oh, but that's because the SVG at this is... It's not... Yeah, it doesn't know... Okay, so this... It should always... These dimensions should always be the maximum size. So if I get to here... So this is the max... This is a scale factor of 1 here. Unless there's another counter scale elsewhere. Yeah, so the scaling happens here, and it's 1. If I get rid of the transform, it'll be that size as well. Yeah, that looks roughly the same. And that's roughly the size I was getting from my render. Okay, so I can get these, I can use these dimensions. Okay. So it's definitely a path that might yield something. It's a little hacky and a little complex, and the DevTools just crashed. And we definitely would have to do some juggling, but it's a fairly low-tech way of doing it. Now, ultimately, the best part, the sort of most complete way of doing it is if we could splice up the SVG as well. Which is a bit tricky because obviously you have one element that could be large. But we don't even care about that too much, right? And the other thing that I've always considered or thought about is if we could split the changing from the non-changing, right? So that the puzzle as it is here... Yeah, the problem is the fog and all this stuff, because the fog can change what's visible and so on. But I mean, there is a little bit of a delay, which I don't like. Like, as I'm clicking, the update takes a little. So then the question becomes, is it faster? I don't know if that's 200 milliseconds, to be honest, right? It could be less than that. Because we saw that the updating of the DOM happens independent of what we're showing. So we're not interacting with the DOM of the SVG, not as far as I know. So we don't actually need the SVG here. Like, it doesn't have to be visible at all. It doesn't need to get rendered. We could completely replace the SVG rendering with a PNG rendering. And maybe that's what I should try working on. Like, considering that we could still use the SVG as the storage of the visual information, but updating the DOM of the SVG isn't actually as bad as I thought it might. It's the pixel rendering that's horrible. And then the question is that 150 milliseconds, is that necessary? Can we improve on that? Because what I suspect is that this function currently does a bunch of stuff that doesn't necessarily have to be done every time, right? So puzzle to SVG, that is kind of the crux of the matter, right? So if I go here, console.time, puzzle to SVG, right? I'm pretty sure that's the heaviest part of it all. If I go here, get my DevTools back if it doesn't crash again. Right, and then we'll do this. So puzzle to SVG. update screenshot, get SVG. Ah, puzzle to SVG. So puzzle to SVG is actually really fast. Wait a second. What is the slow bit then? So the string manipulation is actually not nearly as expensive as I thought. Okay. Hey, Topsy. Hey, Poochie. Give me a minute, okay? Yeah, okay. Stream's gonna be over in like the next 10 minutes, guys. I just need to add this timing. So we are currently doing a PNG type, right? Hey, Poochie. Toby's poking me. Okay, Toby's saying time to end the stream. All right, so this is the last thing we're gonna measure. And then I don't know, the isVAP shouldn't kick in at all. So that shouldn't take any time. And finally, image to canvas. And that could be expensive. Wait. But I don't think that's... We shouldn't be hitting that. We shouldn't be hitting that. Okay, let's see if that's maybe happening. Alright, refresh. It'll take a moment. Because I'm just realizing we did our own image to canvas, right? So we're hitting convert to emoji. Oh, that's the slow one. Oh, that's painful. Especially for a puzzle that doesn't have any. Wow. So that's so expensive? Okay, so this is definitely worth looking into because A, we could sort of in performance mode just disable emojis. And I was just gonna say in this puzzle we don't even have any, except we probably do, i.e. these books. So because what it's currently doing, it's finding all these Unicode characters and then substituting them with SVG images to ensure the rendering is correct. Now, I'm saying this, but that's not exactly correct because that's already happening. It's just, why do I have to do this in this screenshots tool? And is it something that I can skip? I could make it a setting and just not do it. So if we're skipping this, just as an for instance, will it look different? Will the books not render? Because now we're down to 10 milliseconds for the image to canvas. For 4 of them, right? And the URL to image takes 45 seconds. And that's what's usually the expensive part. And update screenshot only takes 27 seconds. So that's actually... Yeah, frameworks. That is a lot better. Because now we're almost at under a frame timing, under 16 milliseconds, right? And 3 frames, I'm okay with that. It's unfortunate that's on the URL to image. Because at that point, wait a second, is that doing the base 64 encoded version? No. URL to image. So, oh yeah, I'm an idiot. That's not because I thought it was too basic. This was generating the string, but this is actually putting the image into memory. So the question is there a way of rendering a partial thing to a canvas that bypasses all of this, and I'm not sure there is. But it's not too bad. It's not too bad. We can definitely poke around into this a bit more. I could create a pseudo renderer that doesn't really replace the SVG rendering. It just it replaces the rendering to screen, right? It doesn't use the SVG engine for display. It uses, you know, images and PNGs. We can try that. All right. I'm running over time, but I feel like I've made more progress than I anticipated. I didn't think I'd get that far. I figured without something more detailed, I wouldn't find anything useful today. Too old, maybe my first programming language was QBasic. Actually, it was Visual Basic 1.0. But it's high school. I taught myself assembly, and I wrote a lot of graphics code in assembly, which I enjoyed very much. All right. Well, Sigma Kunji, thanks for stopping by. Unfortunately, you're just catching me at the end of the stream. But you can join the Discord if you want to discuss the internals of this system. I'm always happy to talk about how things are working. In the meantime, I gotta get going. Thanks for hanging out, everybody, and I'll see you guys in the next stream. And feel free to reach out. Thanks for stopping by, Keith. Always appreciate you.